Hello, my name is Megan, and I'm one of the instructional assistants that teaches at the Math Center. Now today I want to go over graphing rational functions and the steps you can use to take a rational function and give a generalized sketch as well as its components. Now with graphing rational functions, they're typically in, as you can see, a fractional form. We have some value in the numerator and some value in the denominator. These steps for graphing such a thing are as follows. We want to begin first by determining the symmetry of the function. Now, to determine the symmetry, you want to plug negative x into the function. After you plug that in, if the final version of that function looks like the initial function, you have a y-axis symmetry. If you plug negative x in and it turns out that the entire function becomes a negative of itself, you have an origin symmetry. From there, you want to evaluate the y-intercept. That means plugging 0 in for x in the function. To get the x-intercept, you want to set the numerator equal to 0 and solve for x. To find vertical asymptotes, instead take the denominator, set it to 0 and solve for x. Now for horizontal asymptotes, I placed 3 different examples that are typical for determining horizontal asymptote. You need to compare the power of the numerator versus the power of the denominator. As you can see in this case here, the power of your numerator is higher than the power of your denominator, and so there's no horizontal asymptote. In our second example, the power of the denominator is greater than the power of the numerator, and so the horizontal asymptote is 0. And when the powers are the same, like in our final example, the horizontal asymptote is the highest powers coefficients placed on top of each other, so the 4 over 3. And then when it comes to the graphing, you want to plot a point found between the x-intercepts and the vertical asymptotes that you found. Once you have a good set of values, you can get ahead and start sketching. And I'll show you an example with our next slide. Now this function is 2x minus 1 over x minus 1. And based on what we saw for our steps before, we first want to determine any symmetries, if any. And so I want to find what happens when I plug negative x into this function. Each x gets replaced by negative x. And when we further simplify it, our function ends up looking as follows. This function is not the same as the original, and so we do not have the y-axis symmetry. Additionally, this function isn't exactly a negative version of the original, because while it's true that the first terms for both parts are opposite, this minus 1 is not changed. So we do not have a y-axis symmetry or an origin symmetry. So we can say no symmetry. Now we want to determine the y-intercept. So we plug 0 in for x. And in simplifying further, you get negative 1 over negative 1, which will simplify to positive 1. That means in our graph, when we sketch it, we will have a point here. We also want to determine x-intercepts, and recall that x-intercepts are found by setting the numerator equal to 0. And so I set the 2x minus 1 equal to 0. Now in this problem, we want to solve for x. Add 1 to both sides, and then divide 2 on both sides. And with that, our x-intercept is going to be at 1/2. And so if it's at 1/2, I'll make a marking here as follows. Now, our next part is determining vertical asymptotes. So we're going to want to find vertical asymptotes by setting the denominator equal to 0. And Adding 1 to both sides, it looks like your vertical asymptote occurs at +1. So since we have a vertical asymptote there, I'm going to mark that on the function to mark it on the graph as a dotted line. So let's go ahead and mark that as follows. This represents a section of the graph in which the function is not able to pass. Now we'll want to find the horizontal asymptote. Horizontal asymptote we determine by comparing the power of the numerator to the power of the denominator. And it looks like when we look at the 2x and the x, they have the same power. Since their coefficients are 2 and 1, it looks like your horizontal asymptote is going to happen at 2/1, which would be at 2. And so we'll want to mark the horizontal asymptote as well on our graph. There. So at this point, we want to create a table of different values that we might encounter. And you want to determine it with points that are between things such as the x-intercept and the vertical asymptote. So we're going to make a bit of a table down here. I'll choose the points -2, -1, 3/4, 2, and 4. And these are what I'm going to plug into x of the function. Plugging them in, the following values occur. And now that I have these points, we're going to want to mark them on our graph. So let's see, at -2, we go to 5/3. So that's slightly below our horizontal asymptote there. At -1, we go to 3/2. At 3/4, so a little bit after the x-intercept, we get -2. At +2, we get a +3. And at +4, we get 7/3, like so. Our final step at this point is to connect everything together. So using our points and the fact that we can't cross our intercepts, our function will be shaped as follows. Additionally, there's points up here, and so it'll be graphs like this. And with that, we have the graph of our rational function. Now, if you have any other questions or if you want any tutoring on this topic, feel free to contact us at the Math Center. You can get to us through the QList system. Simply sign on as a student into the Math Center, and an IA will be able to help you during our hours. Thank you. Have a good one.